Today we're going to talk about composite area. So we've already looked at composite shapes with perimeter, but we're going to apply that to then finding the area of these shapes. So a composite figure is a shape that can be divided into more than one basic figure. So these simpler figures include parallelograms, triangles, trapezoids, rectangles, squares, any shape that we already know how to find the area of. So if we're looking at this, there's lots of different ways that it could be divided. So I could divide this shape up here and here. I've got a rectangle, and a triangle. I could have divided it still here for a rectangle, but then I could have divided it this way, where I would have a trapezoid and another trapezoid. Okay? This guy, I could divide it here and have a rectangle and two triangles. I could have divided it here and had a triangle and a triangle. So we're just taking these shapes that we can't find the area of because we don't have a formula for them. They're not triangles, trapezoids, parallelograms, any of that. But we can divide it into those shapes to then add up all those areas together. So the steps to finding the area of a composite figure. We're going to divide the figure into rectangles. We're going to highlight the dimensions, the base and height of each rectangle. Find the area of them all and then add them all together to get the total. So even though we divided these shapes into triangles, trapezoids, all that we're going to focus on right now is ones that are divided into rectangles. So let's look at this first example. There's two ways that we can divide this. I could either divide it vertically here and have a rectangle, or I can divide it horizontally. I'm going to put my dividing line here. So normally we highlighted our base and height in different colors. For this, I'm just going to highlight the base and height of one rectangle in one color and the base and height of another rectangle in another color. So the base of this top rectangle is here, the height is there. Then I'm going to do the same thing for the other shape. We have our base of this rectangle, height of that rectangle. So now we need to actually look at the dimensions of it. So there's no base length right here, but we know in a rectangle that the opposite side is congruent, so this must be 2. So for rectangle number 1, the area equals our base of 2 times our height right here, which is 5. So the area equals 10. For our second rectangle, we have a base of 6, height of 6. So it's 6 times 6, which gives us 36. Then we're just adding those together to get our total area. 10 plus 36 is 46. So the total area is 46 centimeters squared. All right, example 2. So I can kind of easily see a rectangle here and a rectangle there. So I'm going to put my dividing line right here. So I'm going to highlight the dimensions of this rectangle on the left, our base and our height. And I'm going to highlight the one on the right, our base and our height. So for rectangle number 1, I can see that our base is 5. If I look at the height here, there's 2 right there, but that's only talking about this portion. There's 2 down here, that's only talking about this portion. We could figure that one out, but the easier route, rather than trying to add all it up here, would be, well, if this side of the rectangle should be congruent to this side of the rectangle. So if this side's 9, this side's 9. So the height of a rectangle is 9. 5 times 9 is 45. For rectangle number 2, our base is 4, our height is 5. 4 times 5 is 20. Then to find our total area, we're adding those together. 45 plus 20 is 65, and our units are centimeters, so 65 centimeters squared. All right, finding the area of these ones. So now these shapes are actually a little bit bigger, and you'll notice down here that we are dividing it into 3 rectangles. There's lots of different ways that you can get to the right answer. You just need to make sure that you're looking at the correct dimensions when you do so. So this first rectangle, I am going to split up right here and here. So I like that I kind of divided it both vertically there. So my first rectangle is the one on the left here. I've got my base here and my height here. My second rectangle is this rectangle up here, base and height. And my third rectangle is this one down here, base and height. So let's look at whichever one we want to start with. I'm going to start with this blue one because this one actually looks a little bit easier. So this rectangle number 1 here. Our base here is 7. Our height here is 3. So 7 times 3 gives us an area of 21. Then I'm going to look down here. Our base, it looks like 15, but it's actually not 15. Okay? Because 15 is talking about the length from here to here, which this portion right here, this yellow portion, is part of this rectangle. So we only want to know the distance from here to here. It's not 15, but if I look across on the other side, that length is talking about from the point here to here, which tells us that our base is 10. So rectangle number 2, the base is 10, our height is 3, which is an area of 30. And then rectangle number 3, there's no measure right here. Again, the 15 is talking about the whole length. We only want the distance from here to here. So how do we figure that out? Well, if the whole distance is 15 and this part right here is 10, we want to know what's left over, which is 5. And then our height, there's nothing listed there, but if we look to the left, it's showing a height of 12. So we have a base of 5, height of 12, which is 60. So we're going to add these together. 60 plus 30 plus 21 is 111 meters squared. All right, this one, so over here I divided it up all vertically, and I kind of like to keep in the method, do it all vertically or all horizontally. This one I'm actually going to divide horizontally, because if I did it vertically, I'd end up with 4 rectangles. I want to do the least amount possible. So I'm going to divide it here and here. And I'm going to highlight all 3 of these. So I've got my first rectangle. I've got my second rectangle. And my third rectangle. Okay. So, rectangle number 1, I've got a base length of 10, a height of 3. 10 times 3 is 30. Rectangle number 2, it doesn't show me the length across here, but then I need to look at the vertical lengths up here. So the length from this point to this point is 2, and this point to this point is 3, which gives me a total length across of 5. I don't see my height over here because the 6 is talking about the whole entire length, but if I look to the left, I see a height of 3 over there. So it's a base of 5 times a height of 3, which is 15. And then the last rectangle, again, it wasn't listed here, but we figured out because looking at the opposite side that this is 3. There's no height here, but on the opposite side it's 3. So we have 3 times 3, which is 9. Then if I add these up, 30 plus 15 plus 9 is 54 centimeters squared. All right, so those are basic ones. Now we're going to look at some word problems. So for these word problems, we're trying to figure out the shaded region. Okay, there's lots of different ways that you can do this. We're going to look at it using kind of one method here. So Jennifer is planting both roses and tulips in her garden. How many square meters of tulips does she need to purchase? So the tulips is this shaded region. So instead of kind of dividing it up, we already have kind of two rectangles. We've got a smaller rectangle here, and we've got a bigger rectangle here. So what we're going to do is we're going to figure out what this bigger rectangle area is, and this smaller rectangle, we're taking out that smaller rectangle. It's not part of the tulip, so we're going to subtract it. So I'm going to highlight. I've got my big rectangle, base and height, and I've got my smaller rectangle, base and height. So rectangle number 1, you have to start with the bigger one since we're subtracting. 12 times 10, which is 120. And then our smaller rectangle, 7 and 2, which is 14. But we want to take away the roses, take away that smaller rectangle. So 120 minus 14 is 106 meters squared. All right, number 6. Again, same idea. Stephanie's backyard has a cement patio and grass. She's planning to get new grass for the backyard. How many square feet of grass does she need to purchase? So the grass is this shaded region. We want to take away the patio. That's not included. So we're going to start with our bigger rectangle and then our smaller one. So the base of our bigger rectangle is 30, the height is 15. 30 times 15 is 450. The base of our small rectangle is 22, the height is 11. 22 times 11 is 242. We want to take away the patio, we're going to subtract it. 450 minus 242 is 208 feet squared. Get your notes checked off and then start the homework number 1.